Okay, now today topic is we are going to compare the EMFs of two cells by using potentiometer. There are several uses are there for the potentiometer. We can compare the EMFs of two cells. We can find out the EMF of a cell. We can also use it to determine the internal resistance of a cell. Now first one use, then how we can compare the EMFs of two cells by using potentiometer, that we are going to discuss. This is very important for the CBSE exam. Okay, and now we know already potentiometer circuit and a potentiometer principle and explanation and construction. Right, let us see. We already know this is the EMF of driving cell, this is the driving circuit, internal resistance and series resistance, and this is totally potentiometer. And potentiometer has a 10 meter wire, okay, that is connected in between A and B. Okay, each one have the 1 meter wire. This is 0 meter location, we take 0 meter, and this is 100 centimeters, this is 0 centimeter, and this is up to here 100. This is a copper strip, and the next this is connected to one more 1 meter wire. 1 meter means 100 centimeters, up to here 100. Next plus 100 is added, here it will become 200 centimeters, and next this is again copper strip, and this is again 100 centimeters, plus 100 we can add, here you will get 300 centimeters. Like this, 100 centimeter, 100 centimeter, 100 centimeter, 100 centimeter, all 100 centimeter wires are connected by using copper strips as shown in the figure, and between A and B the potentiometer wire is connected. And now by using this, how to find out the how to compare the EMFs of two cells. Then the two cells whose EMFs we want to compare, that two cells we can connect it here. Look at here, this is the first cell whose EMF is E1, internal resistance R1, E1 comma R1, and this cell EMF is E2 comma internal resistance is R2. That is connected to the two-way plug key. This is two-way plug key, and this terminal, first cell is connected to point 1 and second cell is connected to point 2, and third point is connected to high resistance, that is connected to galvanometer. The galvanometer end is connected to jockey. This is the jockey, right? This is the jockey, and this is the jockey. Okay, let us see then how we can compare the EMFs of two cells, these two cells, right? That's by using this potentiometer. For that, what we have to do first, listen very carefully and very easy also. First we have to close the plug key K, close plug key K and connect the points 1 and 3. Connect the points 1 and 3. Here 1 and 3 are connected. Then which cell will be inactive? 1 3 is connected means the cell E1 is inactive. This cell is E1 EMF, this cell is E2. Okay, cell E1 is active, cell E1 is inactive. Okay, now the cell E1 is inactive. What we have to do? Okay, now we have to do one thing, that the press the jockey at various points on the potentiometer wire, right? And until the galvanometer shows the zero deflection. Galvanometer shows the zero deflection. For example, at point N1 for the E1 cell, here at point N1 the galvanometer shows the zero. Why the galvanometer shows the zero deflection? Okay, this we will not write in the exam, but we have to know it. Look at here, this from A to this point some potential difference is there, because due to this circuit some current passes here like this. Due to this driving cell some current passes in this circuit. Now there exists some potential difference between these 2 points. If that potential difference, and across the cell also some potential difference is there, even cell is connected because 1 and 3 are connected. Okay, 1 and 3 are connected, points 1 and 3 are connected means E1 cell is active. There exists some potential difference across the cell and across the wire, across this potentiometer wire and across the cell even if the potential differences are equal, at that moment the current through the galvanometer become 0. Why like that? For example, here we have 2 points. For example, here this is 5 volt. For example, here plus 5 volt point and here 0 volt point, and this is connected to another battery, again 5 volt, here plus 5 volt and here 0 volt. Now what is the current passes between these 2 points, or between these 2 points in this circuit? How much current passes? In this circuit there is no current, because the potential difference across these 2 points balances with the potential difference across these 2 points. Then at that moment the potential difference between these 2 points is 0. When the potential difference is 0, then the current is also 0. Like this, when the potential difference across the cell is equal to potential difference across the wire, at that moment the current does not passes through the galvanometer, and the galvanometer shows the 0 deflection. Right? This we will not write in the exam, but we have to know it, how it will shows the 0 deflection. Now, what we have to do? After connecting the 1 and 3, we have to press the jockey at various points. At a particular point, galvanometer shows the 0 deflection. Then note the balancing length. Note the what? Balancing length. Balancing length L1. I will take the balancing length as L1. That L1 is from where to where? A to N1. A N1 is the L1. Okay. Now, according to potentiometer principle, what we write? According to potentiometer principle. Potentiometer principle, we know already, right? Potentiometer principle is V is equal to phi L, we write. V is equal to phi L. Okay? V is equal to phi L, where L is the here balancing length. Okay? V is equal to phi L, and phi is the potential gradient. Here, phi is the potential gradient. We know already. V proportional to L, when the proportionality is removed, we will get a constant, that is phi. V is equal to phi L we will get. This is the potentiometer principle that we can apply at here. Then what you will get? Here the balancing length is L1, we write L1, and the potential difference I will consider as V1. Potential difference between A and N I will consider as V1. V1 is equal to phi L1. But the potential difference across the wire is equal to potential difference across the cell. Which cell is inactive now? E1 cell is inactive. Then potential difference across the cell E1, what happens? Okay. Somewhere duster is missing, I will. Okay, let us see how to find out the potential difference. How to note the balancing length? Where the galvanometer shows the 0 deflection, that point distance from A to, this is 100 centimeters, and this part also we have to add, that is L1. And but V1, what we write? V1 is the potential difference across these 2 points A and N1. But potential difference across this equal to potential difference across the wire E1, right? But potential difference across the cell E1, potential difference across the wire is equal to potential difference across the cell. But what is the potential difference across the cell? Potential difference across the cell we write as, this is the terminal voltage. Potential difference across the cell is said to be terminal voltage. That formula is, first cell is active, that's why E1 minus IR1 we write. E1 minus IR1 we write. But at balancing condition, I is 0, right? Current through galvanometer is 0, means here current through this wire also 0. Then current is 0 means then V1 is equal to what you will get? E1 we will get, right? Okay, this is, we substitute here, then what you will get? E1 is equal to phi L1 we will get, right? This is equation 1. Okay. Now what we have to do? Now remove the connection between points 1 and 3. Points 1 and points 3. 1, 3 are connected, that we can remove now. Okay. Connect points 1 and sorry, 1 is not 2. Connect the points 2 and 3. Right, now we can connect the points 2 and 3. Remove the connection between the point 1 and 3. Now connect the 2 and 3. Okay. Then cell E2 in active is in active, right? Now cell E2 is in active. Look at here. When we remove the 1 and 3, this cell E1 is in open circuit. But we connecting the 2 and 3, that means cell E2 is in closed circuit. This we can draw like this. We will get like this. This is A and this is E2. E2 is connected now. This is E2. Okay. This is 2. This is 3. And this is connected to galvanometer. Okay. That is connected to some jockey. Like this. Okay, look at here. Cell E2 is connected. E1 is not there. Only E2 is there. What we are doing it here, again they follow the same procedure. What procedure? Jockey is pressed at various points, and at a particular point the galvanometer shows the zero deflection. For example, that point is N2. Again note the balancing length 100 centimeters. Plus 100, 200, plus 300, 300, up to here 300, plus this distance 320 or like that. Okay, we have to note the balancing length. And now connect the points 2 and 3. Then E2 is in active. Note the balancing length. Note the balancing length. When we will note the balancing length? If the galvanometer shows the zero deflection, at that moment we have to note the balancing length. Then note the balancing length. Note the balancing length as L2. Note the balancing length as L2. Okay. Now again we have to write the according to potentiometer principle. What we write? According to potentiometer principle. Potentiometer principle. What do you know according to potentiometer principle? Yes, that we know as V is equal to phi L. But here we write as V2 is equal to phi into L2. Okay, the potentiometer principle is what? V is equal to phi L. V proportional to L, that is V is equal to phi L. But the balancing length is L2 and potential difference we can consider as V2. Now here, from here to here we have to take the length as L2. Now potential difference we want. Then for that, potential difference across the wire, right? Now the new, when the cell E2 is active, at the point N2 we got the galvanometer zero deflection. Then we have to note the balancing length. The potential difference across, this is here L1 is what L1? Here note the balancing length as L2. That L2 is from where to where? For example, AN2 is equal to L2. Okay, from A to N2 point, that is L2. And for the second cell balancing length we are noting V2 is equal to phi L2. But V2 is equal, we write as potential difference across the wire, potentiometer wire is equal to potential difference across the cell. But which cell is active? Second cell. Then second cell formula is potential difference across the cell formula is E2 minus IR2. But at balancing condition current is 0. When current is 0, then we write V2 is equal to, here you substitute I is 0, V2 is equal to E2 minus 0, then we will get V2 is equal to E2 only. V2 is equal to, we will get as E2, right? This we substitute here, V2 as E2, then E2 is equal to, we write as phi L2. This is equation 2. Now compare the EMFs of two cells, right? From equation 1 and 2, what we have to do, just comparison means we have to divide the two equations, right? Equation 1 by equation 2 you can do. When you will divide these two equations, we will get E1 by E2 is equal to, we will get as phi L1 by phi L2. Okay, then phi will be cancelled, then we will get as E1 by E2 is equal to, we will get as L1 by L2. This is equation 3. This is how to compare the EMFs of two cells. Briefly I will tell. Okay, this is how to compare the EMFs of two cells. Comparison is nothing but finding the ratio of EMFs of two cells. Okay, and now E1 comma E2 are the EMFs of two cells. Okay, EMFs of two cells whose EMFs are we are comparing, right? That EMFs of we are going to compare EMFs of two cells whose EMFs are compared. Whose EMFs are compared, right? And L1 is the balancing length corresponding to E1 cell. L2 is the balancing length for the E2 cell. L1 balancing length with cell E1, with cell E1. L2 is the balancing length with cell whose EMFs compared, right? And balancing length with cell E1. And L2 is what? Balancing length with cell E2. For the first cell, very simple to compare the EMFs of two cells. Within 1 minute I will tell everything. Okay, and listen very carefully. First we have to connect the 1 and 3. Okay, then note the balancing length as L1. Okay, press the jockey at various points. At a particular point the galvanometer shows zero deflection. That point distance is said to be balancing length, that is L1. For the E1 cell balancing length is L1. We will get one equation E1 is equal to phi L1. For the E2 cell again note the balancing length as L2, then E2 equal to phi L2. You can find out the ratio E1 by E2 equal to L1 by L2. That was very simple. Okay, this is how to compare the EMFs of two cells by using potentiometer. Very important derivation. Okay, whatever that is there on the board that you have to write in the exam, you will get the 3 marks. Okay, the question they will ask like this: explain how you will compare the EMFs of two cells by using potentiometer. Or like this also they will ask, state the principle of potentiometer and explain how you will compare the EMFs of two cells by using potentiometer. This is the procedure, whatever that is there in the on the board, and if you will write that, you will get the 3 marks. Okay, take the screenshot and note it, and I will continue the topic. Okay, let us continue the topic. Previously we discussed the comparison of two cells. Okay, right. Now here we have the two cells, but in the different way they are connecting, right? In the secondary circuit, this is the circuit. Here two cells EMF I want to compare, but differently the circuit is connected now. Here first 1 and 3 are connected. 1 and 3 are connected. When 1 and 3 are connected, then what happens? Then what is the total cell? E1 and E2 are connected in the series, right? E1 and E2 are connected in the series. Previously only one cell is there, now two cells are there. Then the total EMF is E1 plus E2, right? Then balancing length note is, okay, note balancing length as L1. E1, 1 and 3 you can connect. Then note the balancing length as, note the balancing length as L1. Okay, and what is the total EMF? When we connect the 1 and 3, what is the total EMF that is in active? E1 and E2 that are in series. Then the total EMF is E1 plus E2. Then E1 plus E2 is equal, we will get as phi L1. According to potentiometer principle, we have the V is equal to phi L. Okay, but V is equal to E you will get, because V equal to E minus IR, I is 0. Okay, then we will get E1 plus E2 into phi L1. Then 2 and 3 you can connect. 2 and 3 are connected, at the note the balancing length, right? Note balancing length is L2. Okay, now the what is the effective EMF? 2 and 3 connected means these two cells are inactive, but these are in series but wrong connection. These are in series, right connection. Negative terminal connected to positive terminal of the next cell. That is the right connection. Then the effective EMF here we got E1 plus E2. Balancing length is L1. Then E1 plus E2 equal 5L1. Previously what we got? E1 is equal to 5L1. But only one cell is there. But here two cells are there. That's why E1 plus E2. Next time, here this is also series, but the wrong connection. Negative connected to negative. What is the effective EMF? E1 minus E2 or E2 minus E1. Its balancing length you note as L2. Then you will get as equation 2. Now let us find the ratio between these two. Equation 1 by equation 2. We will get as E1 plus E2 by E1 minus E2 is equal L1 by L2. This formula we have to use. Okay, this formula we have to use if A1 greater than A2, if E1 greater than E2. Okay, and sometimes if, okay, this is the note I will write. Note, if E2 greater than E1, okay, if E2 greater than E1, what we write? The comparison we write is like this: E1 plus E2 by E2 minus E1 is equal, we write as L1 by L2. And look at here, this is sum and difference method. Why we say that this is sum and difference method to compare the EMFs of two cells? Why? Because one time the two cells are supporting with each other, total EMF we are getting E1 plus E2. Second time 1 and 3 are connected, two cells are supporting, right connection in series, total EMF E1 plus E2. But 2, 3 connected, wrong connection in series, the two cells are opposite. Then at the moment effective EMF we got difference minus. That means one time sum is there and other time difference is there. This is the sum and difference method to compare the EMFs of two cells. And I drawn one more diagram at here. This diagram is equivalent to this diagram. This and this two are equal. How? Let us see. First cell, this cell whose EMF E0, next internal resistance R0, next series resistance RS, then plug key. Okay, plug key connected to point B. This is the point B. Next, this side positive terminal connected to point A. This is the point A. Next, between A and B 10 meter wire potentiometer wire is there. That directly I am writing between A and B is 10 meter wire. Only one wire I am taking direct. Here 1 meter separate wires connected by using copper strips. But here direct 1 meter wire is there. That means direct like this we are not connecting. Direct we are doing direct one line, one wire. And the next from positive terminal we are going taking to two cells, this circuit. And from the positive terminal from point A, from point A it goes to two cells like this. Okay, same diagram, right? This and this are equal. In exam, sometimes in problems they may give like this, right? And let us continue one problem we will discuss and we will close today's topic. Okay, this is our problem and let us go for the solution of this problem. A long uniform potentiometer wire AB is having constant potential gradient along the length. The null points for the two primary cells of EMF C1 and E2 are in the manner as shown obtained at a distance of 120 centimeters and 300 centimeters from A. Find the E1 by E2 and position of null points with the cell E1. It was very simple problem. Let us see. Okay, this is our diagram. Sum and difference method we have to use it here. And this is the potentiometer. And here first two cells connected like this. Okay. And next the two cells connected like this. Then we write two equations based on this. Right. Look at here. These two cells are connected rightly in the circuit. Like this, if you will connect, then we got the balancing length as 300 centimeters. Okay. When you will connect the cells correctly, right? And now let us see the solution for this. What we want to find out at here. And now cells initially wrongly connected here, cells here rightly connected. When you connect the cells rightly, then the total EMF is E1 plus E2, and the balancing length for that is what? How much? When the cells are rightly connected, the balancing length is 300 centimeters. Yes, that is 300 centimeters. We take it as 300 centimeters. And now the cells are wrongly connected. Look here, minus is connected to again minus. This is wrong connection. Effective EMF is either E1 minus E2. Okay, then we write here the balancing length is 120 centimeters. Okay, they give like this. Then let us see, we have to find the ratio for here. That is, we have formula E1 plus E2 by E1 minus E2 is equal to L1 by L2. In this we substitute, then we will get. Also we have one formula, that is we can from the derivation, right? But we have the formula E1 plus E2 is equal, we will get as phi L1, and E1 minus E2 we will get as phi L2. You know already, phi is the potential gradient. Phi is the potential gradient. Now we can divide the equation 1 and 2. Equation 1 by equation 2 we will do. If we do equation 1 by equation 2, then what you will get? We will get as E1 plus E2 by E1 minus E2 is equal to L1 by L2 we will get. Now we have to simplify by substituting the values. Okay, let us simplify. How to simplify it? The solution I am going to write here, E1 plus E2 by E1 minus E2. You know the values of L1 and L2, right? What is L1 value? 300 by L2 value 120. Here 0 0 cancel. 3 4 ja 3, 10 ja we write, and 2 2 ja 2, 5 ja. We will get as 5 by 2 we will get. Cross multiplication you can do. Okay, 2 of E1 plus E2 is equal to 5 of E1 minus E2. Now we can simplify. 2 E1 plus 2 E2 is equal to 5 E1 minus 5 E2. Then we will get, we can take this to right side and this to left side. Then we will get 7 E2 is equal to 3 E1. Or one more step we can write here. If you write one more step, 2 E2 plus 5 E2 is equal to 5 E1 minus 2 E1. You will get 7 E2 is equal to 3 E1. We want E1 by E2, we will get as 7 by 3. This is E1 by E2. They are asking to find the E1 by E2, and also they are asking to find the, one more question is there, position of null point with the cell E1. Only if the cell E1 we are using, here we are using the two cells, here we are using the two cells, for that we know the position of null point. But only if you will use the E1 cell, then what is the position of null point? That is they are asking. For that, let us see the solution. What you have to do it here, this is equation 1, and from here we write E2 formula it here. From here E2, what we write? E2 is equal to, from this, okay, 3 by 7 into E1 we write. This is equation 2 substituted in equation 1. Okay, if you substitute in equation 1, what you will get? Equation 1 is what here? Equation 1 is that, okay, E1 plus E2, E2 we write as here 3 by 7 E1, 3 by 7 E1 is equal to 5 L1. L1 already we know 300, right? And this we simplify this. This you will get as 10 E1 by 7 is equal to 5 into L1 already we know 300. If you this we can simplify. Here we got as E1 is equal to, this 7 goes to right side, 30 into 7, 210, 5 you will get, or 5 into 210 we will get. 5 into, this 7 goes to that side, 30 into 7, 210 we will get. This is equation 4. 1, 2 completed, next 3 let us consider. No, this is 1, 2, and this we can consider as 3, and this we can consider as 4, and now equation 4 substituted in equation 3. Then this we will get as equation 5. This you can compare with E1 equal to 5L1, right? And the balancing length for L1 we will get as 210 centimeters. Then balancing length for cell E1 is, you can compare, that is 210 centimeters. This is our solution. Okay, thank you for watching my lectures. We will meet in the next lecture.